Good morning students, welcome my channel Bhuloks Mathematics. Last class I have already discussed about the theory of homogeneous differential equation. Let us come and start some important problem related to homogeneous differential equation. Write down the question number 1. X dy minus y dx is equal to root over of x square plus y square into dx. First of all, you have to bring this as a homogeneous differential equation. How? So dx, this term will go to that side. X dy is equal to root over of s square plus y square dx plus y into dx. Dx taking common, we get root over of x square plus y square plus y whole into dx. Okay, now dx will be divided here, x will be divided there. So that can be written as dy by dx is equal to root over of x square plus y square plus y divided by x. First of all, we have to check this is a homogeneous differential equation. This is the first step. First of all, you have to check this is a homogeneous differential equation or not. So how can you do it? So let it be f of xy. Write down f of xy is equal to root over of x square plus y square plus y divided by x. Always put x is equal to tu, y is equal to tv. Write down. Always put x is equal to tu, y is equal to tv. So f of tu tv is equal to, here it is t square u square t square v square plus in place of y it is tv divided by tu. Now t square common, we get t root over of u square plus v square. Here it is tv divided by tu. Now let us take t common. So we get u square plus v square plus v divided by tu. So this t cancelled with this t. So that can be written as t to the power 0. Here it is expressed as f of uv. This is a f of uv because f of xy is equal to x square plus y square root over plus y divided by x. So in place of f of xy, it is as function of f of uv. When an expression expressed in the form of f of tu tv is equal to t to the power 0 f of uv, at that time it is treated as a homogeneous differential equation of degree 0. So write down. So it is a HD homogeneous differential equation. For homogeneous differential equation, always put y is equal to vx. Write down. Always put y equal to vx. Once you put means you have to differentiating on both sides with respect to x. So dy by dx. Here applying the product rule. V plus x dv by dx. So the equation 1 becomes in place of dy by dx we have to put this. In place of y we have to put vx. So the equation 1 becomes v plus x dv by dx is equal to root over of s square. Here it is v square x square plus vx by x. So x square common here. X square common here. We get x root over of 1 plus v square plus it is vx divided by x. Taking x common from whole, x, here it is 1 plus v square plus it is v divided by x. So this x cancelled with this x. Now this v will go to that side. So x dv by dx is equal to 1 plus v square plus v minus v. V cancel. Plus v minus v cancel. Now we have to separating the variable. So we get dv by root over of 1 plus v square is equal to dx by x. Variables now separated. Variables now separated. See here. Variables now separated. Integrating on both sides. Write down. Integrating on both sides. Integrating on both sides. Integrating on both sides. Integrating on both sides. We get dv by v square plus 1 is equal to dx by x. There is one formula, you know, dx by s square plus a square. The integral value is ln x plus s square plus a square. Applying that formula, so we get ln, here it is v plus v square plus 1. Here it is ln x plus applying constant ln c. Depending upon the nature of the problems, you have to supply that type of constants. So here we supply the constant as ln c. So ln a plus ln b, that is ln v plus v square plus 1. Here it is ln xc. So now taking anti-logarithm, ln cancelled on both sides. So we get, now in place of v we have to put y by x. Here we get y square by x square plus 1 is equal to x into c. Okay, so we get simplification, y plus y square plus x square divided by x is equal to x into c. This x multiplied here, we get y plus root over of x square plus y square is equal to x square c. So this is the answer of this question. Very important question, must come in examination. So you have to remember, this is the procedures. First of all, you have to check the homogeneous differential equation. Put always y equal to vx, separating the variables, integrating on both sides, supplying suitable constants, simplify it as far as possible. These are the procedures for the homogeneous differential equations. Now let us take another question. Very important question for CBSE as well as CHSE students. So write down question number 2. Y whole into x cos y by x plus y sin y by x whole into dx is equal to is equal to x y sin y by x minus x cos y by x into dy. This minus will go to that side. Now, here it is dx. So, dx will be divided there. This will be divided here. So, we get dy by dx. Dy by dx. Dx will be divided there. This will be divided here. We get y x cos y by x plus y sin y by x divided by x y sin y by x minus x cos y by x. Okay. So first of all we have to check whether it is a homogeneous differential equation or not. So for that always put x is equal to tu and y is equal to tv. Always this is the procedures. So here it is mxy. Let f of xy as y x cos y by x plus y sin y by x divided by x y sin y by x minus x cos y by x. Okay, so put x is equal to tu, y is equal to tv. Write out f of tu tv is equal to, in place of y it is tv, tu cos tv by tu. Here it is tv sin tv by tu divided by tu. Here it is tv sin tv by tu minus tu cos tv by tu. Okay, so these two cancelled with this t. This t cancelled with this t, so we get f of tu tv. Write down f of tu tv is equal to t cancelled. Here it is t, here it is also t. T is taking common. So this t cancelled with this t, this t cancelled with this t, this t cancelled with this t, this t cancelled with this t. Now t is common from numerator, t is also taken from denominator. So we get it is t is taking common. So we get here it is v, here it is u cos v by u plus v sin it is v by u. Here it is t taking common, so we get u v sin v by u minus u cos v by u. So this t cancelled with this t. So this can be expressed as t to the power 0. Here it is f of uv. Here it is f of uv. So this is a HDE, homogeneous differential equation. For homogeneous differential equation, always put y is equal to vx. So write down, put y is equal to Vx dy by dx, v plus x dv by dx. So this equation 1 becomes, in place of dy by dx, we have to put this. In place of y, we have to put vx. So we get v plus x dv by dx is equal to, here it is y vx x cos vx divided by x plus vx sin vx by x divided by x vx sin vx by x minus x cos vx by x. So this x cancelled with this x. So now taking x from common from numerator, x taking from denominator. So we get, it is v x, it is v whole into this x cancelled, here x cancelled. So we get x taking common cos v whole into cos v, here it is plus v sin v divided by x taking common. So here it is v, here it is sin v minus cos v. Okay, so this cancelled with this x. Now this v will go to that side, so we get this v will go to that side. Okay, so x dv by dx, is equal to v multiplied here, v cos v plus v square sin v divided by v sin v minus cos v minus v. So now this term will multiplied there. We get v cos v plus v square sin v minus v square sin v plus v cos v multiplying. We get v sin v minus cos v. Okay, so this v square sin v minus plus cancelled. So v cos v plus v cos v, that is 2v cos v divided by v sin v minus cos v. Okay, so now separating the variable, we get v sin v minus cos v divided by v cos v into dv is equal to 2 dx by x. Variables now separated. Write down variables separated. Okay, variable separated. Now integrating on both sides. Write down integrating on both sides. Integrating on both sides. Write down V sin V minus cos V divided by V cos V dV is equal to 2 dx by x. So this by this plus this by this by this plus this by this, we get V sin V divided by V cos V dV. This is one integration minus cos V divided by V cos V dV. This is one integration. So 2 dx by x integration ln x plus ln c. So V cancel. Here cos V cancel. Sin V cos V. Tan V. Integration of tan V. It is tan V minus dV by V integration ln V is equal to 2 will be go to the power of x ln x square plus ln c. Integration of tan V dV, that is ln sec V minus ln V is equal to ln x square into c. Ln A minus ln B, that is ln A by B sec V by V is equal to ln x square into c. So this ln cancel on both sides. So now in place of V we have to put y by x. Sec y by x. Here it is y by x. Here it is s square into c. So this multiplied with this. Sec y by x is equal to y by x into s square c. This x cancelled with this x. So we get final answer sec y by x is equal to x y into c. This is the answer of this question. This is the answer of this question. This is a very important problem for council examination, also for CBSE examination. So thank you to all for watching my videos. Please subscribe my channel, like my channel and share my channels.